Hi everyone. Today we're going to talk about the inverse trig functions. So we spent the first part of chapter 9 learning about the trig functions. There are 6 of them: sine, cosine, tangent, secant, cosecant, cotangent. And basically today we're going to talk about the inverses. And I'm going to start off with notation because there's 2 ways to write inverse for the trig functions. The first way is kind of the more standard way. We use the same inverse symbol we use for anything else, like f inverse of x or any inverse function like that. And that's the little, what looks like an exponent of -1. And it goes after the name of the trig function, but before the angle. So I gave you an example using cosine. I said if you see the cosine and then the little -1 and then x, that's inverse cosine of x. Now, there's a second way to say the exact same thing. If you ever see any of the 6 trig functions with the prefix arc, A-R-C, in front of it, that's the exact same thing. So if I said here, I would just say that arctangent of theta, and I would just say arctangent, but it means inverse. It's literally the exact same thing. So it's one thing that can be a little bit confusing, and I want to make sure you guys really understand this. It doesn't matter if I say inverse tangent or arctangent, I am saying the exact same thing. So here's the definition of an inverse trig function, and I use sine. I could have used any of the 6, but I use sine for my definition. I said sine of theta equals x. I just kind of made up an equation using an angle and a variable. Then I have that little double arrow. That double arrow means like if and only if. It means each thing implies the other. And then inverse sine of x equals theta. So here's a good way to think of this. We said way back in chapter 1 when we were talking about inverses, I told you guys the number one thing I want you to remember for inverses is inverses switch x and y. That's what they do. And that's really what we're doing here if you think about it. If you look at this, to get from sine to inverse sine, I just switch these two things. Instead of having the theta attached to my trig function, I have the x attached to my inverse trig function. And instead of it equaling x, it equals theta. So that's a good way to think about these. If this is kind of a, like from an equation way of thinking about it. If I said cosine of pi over 6 equals radical 3 over 2, which it does, that's a unit circle value. I could change this into an equation using inverse cosine by just switching those two numbers. So basically inverse cosine of radical 3 over 2 equals pi over 6. And it works changing back from inverse to regular too. So for another example, let's say I said inverse tangent of 1 equals 45 degrees. I'll use degrees this time. I could change that into a regular tangent by doing the same thing, by just switching those two numbers. And you would end up with tangent of 45 degrees equals 1, which if you check on the unit circle is another true statement. So basically that's kind of an equation way of thinking about inverses. If you have a regular or an inverse trig function and you want the other thing, just switch the two numbers in the problem and it'll change from one to the other. Now another interesting thing while I have this one on the board, notice that in that question, theta is an angle. We know it because right off the bat, the first thing I said is sine theta. Whenever you have a trig function, what comes after it is an angle. Now the reason I pointed that out is because inverse sine of x equals theta. So when you do your inverse trig functions, the answer is an angle. And that's important. You know, if I ask you what is inverse sine of x, and your answer is root 3 over 2, it's automatically wrong. You know, that you got the question backwards. You gave me the wrong answer. Your answer needs to be pi over 4 radians or 180 degrees. You know, it can be in degrees or radians, but it definitely needs to be an angle. All right, so let's switch gears now and talk about how to actually evaluate an inverse. Now remember, inverses work questions backwards. So the first time we did unit circle, I basically gave you an angle, you found the point on the unit circle, and then you use that point to answer questions about sine, cosine, or tangent. Well, this time I'm going to give you the value. You're going to have to use the value to figure out the point, and then once you figure out where the point is, you're going to use that point to answer the question with the angle. It works it completely backwards. So here's a good way to think of it. Earlier in the chapter, I said, find cosine x. And I'm basically asking you, what is the cosine of angle x? Well, inverse cosine of x says the cosine of what angle equals x. I'm basically giving you the answer to the question and asking you to find the angle where that happens. So that's what we're doing. When you're doing inverse trig, you're doing the same questions that we've done using the unit circle, but you're working them backwards. So let's try one out. Let's do inverse cosine of 1/2. And when you see that question, this is what I want you to think to yourself. When I ask you guys, what is the inverse cosine of 1/2? What I'm asking you is the cosine of what angle equals 1/2. So this is what I think to myself. I'm going to draw a little mini unit circle down here. I want cosine to equal positive 1/2, so my answer is definitely on the right side of the unit circle. Definitely. Because remember, cosine is a horizontal component. It's positive to the right, negative to the left. Now, if cosine equals 1/2, remember 1/2 is the smallest unit circle, so that's the smallest value on the unit circle. So basically that's like one step over. But it could happen in two different places. It could happen at this angle right here, or at this angle down here, because this is the point 1/2 comma radical 3/2, and this is the point 1/2 comma negative radical 3/2. So basically what we're getting is two answers to this question. So I said on the unit circle, this happens in two different places. That top angle in radians would be pi/3, in degrees it would be 60. And that bottom angle in radians is 5pi/3, or in degrees is 300. So what we're getting right now is two answers. And I want you to realize we're just looking at the unit circle. If you include coterminal angles, there are an infinite number of solutions. Because if I take either one of the answers from the unit circle and start adding or subtracting full rotations, either 2pi or 360 degrees, I'm going to keep getting answers over and over. So like if I take that first answer, pi/3, if I add 2pi, that's an answer. Add 2pi again, that's an answer. Add 2pi again, that's an answer. There are an infinite number of solutions to every inverse trig question. So if you think of it this way, I like to think of calculators. If I grab a calculator and I type that last question we just did, inverse cosine of 1/2, the calculator isn't going to say infinitely many solutions. It's not going to start listing all of them. It's not even giving me both answers from the unit circle. It's going to give me one answer. Anytime you type something on a calculator, it gives you one answer. So this set of rules has been created to pick the one main answer. Let's start with cosine, because that's the easier one. With cosine, you always get, remember our last picture looked like this. Let me draw it again real quick. Our last picture, our two answers looked like this. Now, it's always symmetric like that. You always get a mirror image, one answer from the top and one answer from the bottom. So for cosine, it's very simple. We're going to take the one from the top. So inverse cosine, we always take the one between 0 and pi, or the top of the unit circle. Now, that's super easy. That's probably what you would have done anyways. If I said our two answers were pi/3 and 5pi/3, pick one, most people would pick the pi/3. They take the first one off the unit circle. So cosine's kind of easy. Now sine and tangent are a little bit trickier. Sine, you get that same mirror image, but for inverse sine, you get one on the right and one on the left. And you say, we want the one on the right. For inverse sine, we're going to take the one on the right. But see, here's the problem. When you're doing inverse cosine, you're taking the one off the top, it's between 0 and pi. But that doesn't really work. If you're taking the one from the right, you have 0 to pi over 2. And if you're going forwards, you have 3 pi over 2 to 2 pi. So you have two separate intervals. Now we don't want two separate intervals. We want one connected interval. So what we're going to do, in fact, the only way to do it as one connected interval is to start here and say my interval is going to go from here to here. The only way to connect those two intervals is to use negative angles. To say this bottom is negative pi over 2 and this top is positive pi over 2. So basically for sine, and tangent ends up working out the same, I'll show you that in just a sec. This is the weird part. Like sometimes when you type inverse sine of something or inverse tangent into a calculator, it gives you a negative number for an answer, because that means your answer is coming from the fourth quadrant and that's what it's programmed to do. So it's kind of weird. I just want you to be aware of that. As far as tangent, let me show you real quick. Tangent is when you get two answers, it always ends up being exactly halfway around the circle from each other. You get like a perfect straight line going through the circle. But again, you're getting one from the right and one from the left. So for tangent, we use the one from the right. We use our sine rule. So basically, you have that kind of weird rule. Let me show you an example of how that works, and then I'll talk to you guys about what we're going to do with it. So let's evaluate arc sine of -1/2. So right off the bat, I used arc instead of inverse. I want to switch back and forth to remind you that those mean the exact same thing. When you see a question like this where it says arc something, in this case sine, that's the exact same as inverse sine. Don't be confused by it. Don't think it's a different question or a harder question. It's the exact same question, but using a different notation. So we have arc sine of -1/2, and this time I said answer in radians, please. So again, let me just put it into words one more time. What I'm asking you guys is, for what angle does sine equal -1/2? So let me do my unit circle down here again. Do a little sketch of one. Now we're doing an inverse sine, and the answer is negative. So this is definitely from the bottom of the unit circle. Remember, sine is your vertical component. If that was a positive number, it would be on the top. Negative is on the bottom. And then the way I like to think of it, the same thing I just did for cosine. 1/2 is the smallest value on the unit circle. So it's basically, if you start at the middle, it's one angle down on each side. So my answer could be right here or right here. Those are the two places where sine equals -1/2, because it's down for negative and down one tiny little piece for the 1/2. So I found my two angles. Remember, in the directions I asked you to answer in radians. So what we get is 7 pi over 6, that would be the one on the left there, and 11 pi over 6. Now if we're doing a true inverse, like let's say I typed this into my calculator to see what it was, I actually wouldn't get either of those answers. Because remember, the rule is for inverse tangent, we're going to choose the one from the right. So first of all, let's just throw out the 7 pi over 6. That one's gone. I'm choosing the one from the right, so I'm kind of picking the 11 pi over 6. But remember, the way we do it, we don't call it 11 pi over 6. We count that using a negative angle. And if I'm counting that going backwards, that would be -1 pi over 6, or negative pi over 6. Now, I want to make one thing very clear to you guys. I'm teaching this rule to you because I want you to understand it and know where it comes from. But the most important thing, by far, is that you can get these two answers here. When it comes to actually using inverse trig, the time we use them the most is solving trig equations. And when you're solving trig equations, the two I circled in yellow are the answers we want. So don't spend too much time worrying about this. If this rule seems confusing to you, it is confusing. It's weird having to give negative angles for inverse sine and inverse tangent. It's weird having to pick one of the two answers off the unit circle. This is just so you understand, like I said, it's mainly for calculators. So if you're doing a question, you're thinking the answer should be 7 pi over 6 and 11 pi over 6, but you type it into a calculator and it comes out as negative something, now you know why. But really what I'm mostly concerned with is that you guys could find those two answers I circled in yellow. Okay, now let's talk about inverse tangent, because inverse tangent can be a little bit tricky. So when you're doing inverse sine and inverse cosine, we just did one example of each, and we know those numbers from the unit circle. Like I say, you know, inverse cosine of 1/2, we know where that happens. Inverse sine of negative 1/2, we know where that happens. See, tangent is different because tangent you have to build from sine and cosine. You don't actually see the final answer on the unit circle. So you have to look for patterns, and let me show you a couple of them, and I think you'll see what I mean. So first of all, let's just, using the unit circle, figure out what tangent of pi over 3 is. So on the unit circle, pi over 3 is this angle right here, and it's the point 1/2 comma radical 3 over 2. So let's start with that. So if I was trying to figure out tangent, what I'm really doing is sine of pi over 3 over cosine of pi over 3. Remember, tangent is sine over cosine, so I'm going to use those values. So from the unit circle, that would be radical 3 over 2 over 1/2. And when you simplify it, the 2's would cancel. You would get radical 3 over 1, or basically just radical 3. Okay, so you can see it took a few steps, but from the unit circle, I figured out that tangent of pi over 3 is radical 3. Now here's the problem. The question, if we're doing inverses, is just going to say, what is inverse tangent of radical 3? And you're not going to be able to look at the unit circle and say, okay, well, where do I see a radical 3 on the unit circle? You're going to have to work this question backwards and figure out what that angle is. That's what I mean by looking for patterns. So to evaluate inverse tangent of radical 3, you got to figure out where that radical 3 came from. You got to work that process backwards. You got to say, well, okay, so if I do sine over cosine, and the answer is radical 3, what were sine and cosine? And then when you figure out those numbers, you have to figure out where they are on the unit circle, and that's how you find your answer. Now here are some other ones. Tangent of pi over 6. So again, I typed it all out this time, but basically you would have to you'd have to find pi over 6, do sine over cosine. It would end up being 1/2 over radical 3 over 2. The 2's would cancel. You would get one of those two things. This is the unreduced one here. I actually kind of typed it backwards. I should have flipped those two around. This one is if you rationalize the denominator. So basically, yeah, I kind of typed it out of order. It goes from here to here and then back to here. So if I give you the question like this, if I say what is inverse tangent of 1 over radical 3, that one's not too bad because you can kind of see that it came, you can see the 1 in the radical 3. You can see that it came from having 1/2 over radical 3 over 2 and figure out, okay, I'm looking for the place where sine is 1/2, cosine is radical 3 over 2, and that happens at pi over 6. Now this is the hard one. If I ask you what is inverse tangent of radical 3 over 3, you got to realize, okay, well, unreduced, that's 1 over radical. You got to work the whole process backwards. So inverse tangents are definitely harder than inverse sines and inverse cosines. Here's pi over 4. So tangent of pi over 4, sine over cosine, they're both the same. They're both radical 2 over 2, so you get 1. But again, working that backwards, the question is just going to say, what is inverse tangent of 1? And you're going to have to realize that happens when sine and cosine are the same. That happens when they're both radical 2 over 2. That happens at pi over 4, or 45 degrees, and that's the answer to the question. The last one would be 0. That's the very beginning of the unit circle. Tangent of 0 is 0. That means inverse tangent of 0 is also 0. It's kind of an easy one to remember. And then the only other thing is I kind of focused only on first quadrant. Well, first of all, the answer can be in degrees or radians. for inverses. And then what I started to say is, if the number is negative, the angle will be 2. So if I ask you, like, what is the inverse tangent of -1? Instead of 45, it would be -45. Or if I ask you, what is the inverse tangent of radical 3? Or negative radical 3, instead of positive pi over 3, it's negative pi over 3. So the tangents are a little tricky. You gotta be careful with those. Now, the last two examples I want to do with you, the book, in today's homework, you're going to see these ones where it's a combination of one regular trig function and one inverse trig function. So what you always want to do on this type of question, you always look here first and see if you can evaluate that using the unit circle. And this time we can. So inverse tangent of 1 was 45 degrees. That means inverse tangent of -1 is -45 degrees. And that's what I meant by the negatives. If you know those 4 patterns I showed you and any one of them shows up, the answer just comes out negative. I also said you could answer in degrees or radians. I chose degrees, but if you put -pi/4, that's fine also. So I did the inside part. Now the second part of this question is to find the sine of that angle. So once you figure out what's inside the parentheses, if you can get an angle for that, it just turns into a trig question. So now all of a sudden it's unit circle. And I think, okay, my angle is -45 degrees or -pi/4, which would be right here, right down the middle of the 4th quadrant. It's pi/4, but going backwards. It's the same as 7 pi/4, basically, if you're thinking, oh, I switched to radians, but you guys get the idea. So that point would be positive radical 2/2, comma, negative radical 2/2. Positive because it's to the right for x, negative because it's down for y. Now, this is a sine question, and sine is the second one. So the answer to this question is negative radical 2/2. So that was a combination, it was unit circle both times, but it was a combination of an inverse trig question and a regular trig question. You just had to do them separately. Now for our last example today, I'm going to do a similar question, or I should say a question that looks similar but is very different. And the reason is, that's not a unit circle angle. That's asking me, for what angle does sine equal 2/3? Not in the unit circle. And remember, one of the things I mentioned earlier in this chapter, our 2 main trig tools are unit circle and SOHCAHTOA. If something's not unit circle, try to make a triangle for it. So I'm going to do that. I'm going to say, basically, this is telling me for what angle does sine equal 2/3. If I drew that as a picture in a triangle, here's my angle, I'll call it theta, and I'm telling you that basically sine of that angle is 2/3. Well, from SOHCAHTOA, let me label the sides here. This would be the hypotenuse. This would be opposite from theta. This would be adjacent. And from SOHCAHTOA, sine is opposite over hypotenuse. So opposite would be 2, hypotenuse would be 3. And now what I can do is I can find the third side, adjacent, using Pythagorean theorem. So let me do the work. A squared plus b squared equals c squared. And that would be, the c has to be the 3. We'll call one of these x and the other one is the 2 for the legs. So you get x squared plus 4 is 9. Oops, I don't need that equal in there. Get rid of that. X squared plus 4 is 9. You subtract the 4 from each side. And x squared is 5. Take a square root. And you get, now this is one of those, we saw it in last section also. Technically you're getting a plus or minus here, but if you're a triangle, we'll just leave it a positive. So my missing side is square root of 5. And now that I've wrote out my triangle, what you're really being asked to find here is tangent. And you're going to use SOHCAHTOA again. So for your final answer to the question, tangent is opposite to over adjacent radical 5. And remember, I told you guys, you can, for me, I'm fine with you guys leaving radicals in the denominator. The other thing would be if you want to multiply by radical 5, if you like rationalizing denominators, the other possible answer here would be 2 radical 5 over 5. I don't need you to do that work. I'm okay with either one of those answers. But the idea is our two main tools right now are unit circle and triangle. Unit circle is easier. You can do that, do that. But if you get a value like this, inverse sine of 2/3, you can't use unit circle. Do this work here. Draw a triangle for it and use SOHCAHTOA to answer whatever the question is.